This is the first top predator to have roamed the earth. It is called Anomalocaris. Anomalocaris, now extinct, lived about 541 million years ago, during the Cambrian period, long before apex predators like big cats and frightening lizards joined the lineage. It was just about 3 feet long. During this period, the earth was a lonely place. Only few animals coexisted with Anomalocaris, and all of them were not massive creatures. As time went on, numerous creatures, both large and small, began to evolve until about 150 to 100 million years ago, during the Mesozoic era, when everything changed. The earth suddenly became a host for a variety of moving giants, including the largest creatures to have ever walked the earth. These are the dinosaurs that could reach lengths of up to 121 feet and weigh about 70,000 kilograms. Other species like the Brachiosaurus easily surpassed lengths of 70 feet and weighed between 30 and 80 tons. Majority of the largest creatures to have ever roamed the earth lived during the Mesozoic era, approximately 251 to 66 million years ago. This era is called the Age of Reptiles. It spanned about 180 million years and was recognized by the dominance of reptilian life forms across terrestrial, aquatic, and aerial environments. Almost all of the prehistoric creatures are larger than their modern counterparts. Take the Sarcosuchus imperator for example. It is an extinct crocodile that lived about 112 million years ago. Now, despite the fact that the saltwater crocodile is the largest living reptile on Earth, it is simply dwarfed by Sarcosuchus, its prehistoric counterpart. This is also Arthropleura, the largest millipede to have ever existed on Earth. It could reach about 8.5 feet in length and grow over 2 feet wide. Modern millipedes barely reach 1 foot in length. The same occurs to monitor lizards and even sharks. The list never ends. There are countless of instances where a prehistoric creature dwarfs its modern relatives. Fast forward to this present day, the largest land animal is the African bush elephant. However, the largest animal on Earth is the blue whale, which can reach approximately 105 feet in length and weigh about 200,000 kilograms. These animals are the only creatures whose size could compare to the largest prehistoric creatures. One of the most critical factors affecting animal size over time has been changes in atmospheric composition, specifically oxygen levels. During the Carboniferous period, about 359 to 290 million years ago, oxygen levels were significantly higher than they are today, with estimates suggesting that up to 35% of the atmosphere consisted of oxygen, compared to the current 21%. This higher oxygen content enabled animals to grow larger, particularly those with respiratory systems that relied heavily on passive diffusion, such as insects. Meet Meganeuropsis permiana. It is a griffin fly which had a wingspan of about 2.5 feet. Such creatures thrived in these conditions because their oxygen requirements were easily met by the environment. As oxygen levels declined, large-bodied animals, especially those with less efficient respiratory systems, faced increasing challenges. Modern-day oxygen levels, lower than those in prehistoric times, have limited the size of terrestrial animals, as their bodies must be able to efficiently absorb and distribute oxygen to survive. There is one common feature that runs through almost all of the fossilized sauropod dinosaur bones discovered so far: a complex system of air sacs. Most of their vertebrae and bones had holes that ran through their entire skeleton. These holes accommodated large air sacs, which made oxygen exchange more efficient, crucial for sustaining the metabolism of their massive bodies. Humans have dense and heavy bones without a system of air sacs. This puts a limit on how big we humans can grow. According to evolution, The human skeleton has reached the maximum limit of the weight it can hold. An overgrowth will eventually lead to the body collapsing under its own weight. However, sauropod dinosaurs with air sacs have extremely light bones, meaning their bones can grow very large and strong without sacrificing too much energy to move their body. Additionally, a lot of studies on dinosaur bones have revealed that many giant dinosaurs grew very fast, and it took only about 20 years for them to reach their full size. Scientists believe this might be the strong factors which caused gigantism in these creatures. During the Mesozoic era, when dinosaurs roamed the Earth's climate was warmer and more stable, creating a lush environment conducive to supporting large herbivores, and consequently, the large carnivores that preyed on them. Cold-blooded animals like reptiles benefit from warmer environments as they grow larger, without expending energy on heat regulation. In contrast, the ice ages and the subsequent global cooling after the extinction of the dinosaurs created environments that were far more hostile. With colder climates, food resources became scarce, and animals adapted to these changing conditions. Smaller body sizes became advantageous because smaller animals require less food and energy to survive. Giant species could not adapt fast enough, leading to a mass extinction. In modern times, ecosystems have become even more constrained by human activities, further limiting the resources available for large animals to thrive. The expansive forests and plains that once existed are now interspersed with cities, roads, and farms, reducing the range of many species and limiting their potential size. The next evolutionary factor that promoted large body size is predation. In the prehistoric ecosystems, larger body size was often a defense mechanism. However, with the decline of giant species, smaller and faster animals began to dominate. As the ecosystems diversified, speed, agility, and intelligence became more advantageous traits than sheer size. Take the cheetah for example. Unlike other big cats, the cheetah has traded overall body size for speed and stamina. In the animal kingdom, speed can sometimes be the difference between life and death. Modern top predators such as lions, tigers, and orcas are far more smaller than their prehistoric counterparts, but they are efficient hunters with complex social behaviors, keen senses, and complex hunting strategies. Modern ecosystems have evolved to favor such traits over gigantism.